Welcome everyone. I am Mahenoor Yusuf and I graduated from Harvard Business School in 2016 with the PLDA. I'm also leading Harvard in Tech Seattle chapter. Harvard in Tech is the official Harvard University-wide alumni group for technology. We hope to further the development of technology through encouraging innovation, providing resources and network, and promoting technological activity throughout the Harvard community. This webinar is getting recorded and will be available at the Harvard in Tech Seattle webpage. So today's panel discussion is about Microsoft Cloud Intelligence, aka AIOps, infusing AI into cloud computing. I'll be moderating this webinar with my colleague here with Anastasia.
Hello, everyone. I am Anastasia Chernykh. I am Vice President of Sales and Consulting for Alera Group Orange County and a Program Manager for the webinar series at Harvard in Tech Seattle. I have the absolute pleasure to introduce our distinguished panelists today, starting with Dr. Dongmei Zhang, who is joining us from Beijing, China. Thank you for accommodating our time zone. Dr. Zhang is a distinguished scientist of Microsoft Research Asia, where she leads the research area of data, knowledge, and intelligence. Her groups, aside from doing actual research, also collaborate closely with various product teams at Microsoft and have transferred multiple technologies, innovative technologies, into core products. Dr. Zhang earned her PhD in robotics from Carnegie Mellon University. Welcome, Dr. Zhang.
Thank you.
Our next panelist is Dr. Marcus Funtora. Dr. Fontoura is joining us from Seattle, Washington, so not quite as far away as Beijing. And he is currently a technical fellow in Microsoft, where he works as chief architect for Microsoft Azure Compute. In his previous roles at Microsoft, he has worked on production infrastructure for Bing and in multiple Bing ads projects. He has over 25 patents issued and over 50 published papers. Welcome, Dr. Fontoura.
Thank you. A pleasure to be here.
Thank you for joining us. Third panelist joining us today is Murali Chintalapati, also from Seattle, Washington. We just brought a whole bunch of Washington people in. And he is a partner group engineering manager in the Microsoft Azure team. His team develops end-to-end AI and analytics solutions. Their focus spans multiple areas from product reliability to span and scan of the production platform. And their research focuses on enhancing the customer experience. Welcome, Mr. Chintalapati.
Thank you, and hello, everyone.
Absolutely. Our final panelist, you guessed it, also from Seattle, Washington, is Igal Figlin. Igal is focused on building the best cloud compute system in the industry. He is currently managing the fundamentals team in Azure Compute. He is doing a ton of work that focused on initiative across Microsoft and encompasses customer app lifecycle and platform scale. His previous roles included roles in Azure and security divisions of Microsoft. Welcome, Mr. Figlin.
Thank you. It's amazing to be here.
Welcome all. Mahenoor, over to you.
Thank you, Anastasia. Welcome, everyone. Thank you for joining us today. We are so honored to have you here. So artificial intelligence enhances the speed, precision, and effectiveness of human efforts. Today, the amount of data that is generated by both humans and machines far outspaces humans' ability to absorb, interpret, and make complex decisions based on that data. Artificial intelligence forms the basis for all computer learning and is the future of all complex decision-making. AI and its logical evolution of machine learning and deep learning are the foundational future of business decision-making. The global AI market size was valued at 62.35 billion USD in 2020 and is expected to expand at a compound annual growth rate of 40.2% from 2021 to 2028. And revenue forecast in 2028 is around 997 billion US dollar. The continuous research and innovation directed by the tech giants are driving the adoption of advanced technology in industry verticals, such as automotive, healthcare, retail, finance, and manufacturing. However, technology has always been an essential element for these industries, but AI has brought technology to the center of organizations. For instance, from self-driving vehicles to crucial self-saving medical gear, AI is being infused virtually into every apparatus and program. AI is proven to be the significant revolutionary element of the upcoming digital era. Tech giants like Amazon, Google, Apple, Facebook, IBM, and Microsoft are investing significantly in the research and development of the AI. These companies are working to make AI more accessible for enterprise use cases. As part of the AI series, our first webinar is a collaboration with Microsoft. The topic of today's discussion is Microsoft Cloud Intelligence, AIOps, infusing AI into cloud computing. So in today's discussion, we are going to explore how Microsoft scientists approach cloud computing, the translation of research into product strategy, applications of AI in Azure, as well as a discussion on recent technologies. This conversation will bring a holistic view approaching AI from research, product strategy, engineering, and customer experience perspective. So let's move on to our panelists today. The first question is directed to Dr. Zhang. As a distinguished scientist and research lab director at Microsoft, what are your lab's research area and key accomplishment in the technology field? Can you speak to what makes the topic of AI ops particularly relevant today?
Okay. Thanks, Mahenoor, for the question. Really great pleasure to be here. I've been working with Microsoft Research Asia for almost 20 years. Our lab was founded in 1998. Over the years, our labs has a number of focused research areas, including computer vision, natural language processing, like big data and knowledge mining, natural user interface, system and networking, computer science fundamentals, and also computational science in recent years. So like I mentioned, over the years, MSRA as a lab has made, I would say, significant contributions to the computer science research communities. In addition to that, we also have like tech transfers to impact the products of Microsoft. So let me try to capture the compliments from those two aspects. In terms of the research contributions, MSRA over the years has published more than 5,000 papers, scientific papers, at the top academic conferences and also the leading academic journals. Like more than 50 of them have won the best paper awards. So I think that just shows that the research strength of MSRA is very well recognized by the research community. In recent years, like Mahenoor just mentioned, right, the AI, we have seen great breakthroughs in artificial intelligence, and our lab has been like working really hard along this direction as well. And gladly, we also made some very good progress. For example, we have technologies from the lab surpassed human parity or achieved state-of-the-art results in challenges like ImageNet, Squad, MS Coco, and Stream, etc. Here, I would like to use a very specific example. It's called ResNet. ResNet comes from the name Deep Residue Network. So it's a deep learning algorithm for computer vision. It was proposed by the researchers in MSRA in 2015. Actually, that particular algorithm has achieved groundbreaking research result in the computer vision field, and it was a major leap forward in AI research. So nowadays, when you work on computer vision problems, and then this ResNet has already become the classic technology, or the one of the standard deep neural network architecture for people to use. So from there, you can see the impact of the work. So so that's one. And then another example I would mention is that MSRA has also contributed actively to the open source community. For example, we have this Light GBM. It's a machine learning framework. It has been very popular in the open source community, and many people, many researchers, students, professors, practitioners from industry, are actively using that. So that is our contribution from the research perspective. And then, like I mentioned, I also want to touch upon our contribution to Microsoft products. So, as one of the missions of Microsoft Research, we should do our best to transfer technologies into Microsoft products. We should help to ensure that Microsoft products have a future. So over the years, our researchers have been putting a lot of effort in that aspect as well. Almost every Microsoft core product has technology contribution from MSRA. So today, I'm very, very happy to have this opportunity to be here with our partners, our colleagues from Azure, to do this. Talking about AIOps, so I think that's one of the focuses of our area in recent years. So very glad that we a few years back we proposed this research direction as a strategic direction for research, and also we shared the idea with our colleagues in product teams, and definitely they had they were thinking along very similar lines. So that was really a shared vision between research and our product teams. So I think. Since AIOps is our topic today, I think it will be good for us to get to know why we want to work on AIOps first, and what is AIOps. So to do that, I actually recorded a short video for us to see. So it would be great, Mahenoor, if we could play the video.
Excellent. Let me go ahead and do that.
Hello, everyone. I'm Dongmei Zhang from Microsoft Research Asia. First, I'd like to thank Harvard InTech Seattle for this invitation. Together with my colleagues in Azure, very glad to have this opportunity today to talk about cloud intelligence, aka AIOps, and share our experiences in infusing AI into cloud computing in Microsoft. I'll first talk about why cloud intelligence is important. Then I will introduce what cloud intelligence is with a couple of examples. When talking about the motivation of our work, let's take a moment to look at what was happening in the software industry in the past 10 to 15 years. One significant paradigm shift was the migration to cloud computing. More and more businesses in different industries have realized the benefits to migrate to the cloud in the era of digital transformation. Businesses need to collect huge amounts of data, store the data, process the data, get insights from the data, and use the insights to improve their existing businesses, as well as create new business opportunities. They need to do all of these at scale with low cost and high agility. They cannot afford to use the traditional IT approach to achieve this, especially for small and medium businesses. Therefore, cloud computing would be a natural choice for them. Gartner's predictions also support the migration to cloud computing. The table on the left shows the percentage of cloud shift in the next few years after 2018 for different types of software. The table on the right shows the predicted market value for different types of cloud services from 2019 to 2022. For almost 2 years, COVID-19 has made a huge impact on business, society, and human life. Here are some numbers. In April last year, there were more than 200 million Microsoft Teams meeting participants in a single day, generating more than 4.1 billion meeting minutes. Also, Teams had more than 75 million daily activity users. As our CEO Satya put it, we've seen 2 years worth of digital transformation in 2 months. In short, the pandemic has made the role of cloud computing platforms even more critical. The implication of this is profound. It means that cloud computing platform is becoming part of the basic infrastructure of our society. The non-functional properties of cloud computing platforms would become immensely important, including availability, reliability, performance, security, etc. As researchers in the industry research lab, we have experienced the impact of the trend of cloud computing. On one hand, Azure is one of Microsoft's big bets. It has massive scale with deployment in more than 60 regions in the world and millions of physical machines. On the other hand, cloud computing and the digital transformation it enabled got us to think about digital transformation and the software industry. On the surface, the question might seem odd since software is naturally digital. But deep down, the question is really about how we develop software, operate software systems, and engage with customers. In 2009, we proposed a new interdisciplinary research direction called software analytics. It utilizes the data-driven approach to address various challenges in the software domain. We realized that it actually is the digital transformation of the software industry itself. Given the paradigm shift to cloud computing, we focus our software analytics research on cloud computing. We call this new topic cloud intelligence. Now let's look at what exactly cloud intelligence is about. Cloud intelligence is to utilize AI ML technologies to design, build, and operate complex cloud services at scale. Centered around the 3 key elements in cloud computing: service, customer, and engineering, cloud intelligence has 3 major topics: AI for system, AI for DevOps, and AI for customer. The North Star of cloud intelligence is for cloud services to have built-in intelligence, meaning they should monitor themselves, analyze and assess the status, and they should be capable of self-adjusting and adapting to new conditions. Of course, there will be developers and operators in the loop when needed. With such intelligence, when dealing with service issues, the services will be proactive instead of reactive in order to minimize customer impact. Working with our colleagues at Microsoft, we have been promoting the research and practice of cloud intelligence, both inside and outside Microsoft. We initiated the Cloud Intelligence Workshop series in research communities with steering committee members from both academia and industry. The first workshop was at AAAI 2020, and the second one was at ICSI this year. With this effort, we hope to create a forum for researchers and practitioners from AI, software engineering, and system communities to work together on this exciting interdisciplinary research topic. In recent years, AIOps has become a very popular word. It was first coined by Gartner in 2017 to refer to the application of machine learning and data science to IT operation problems. Compared to cloud intelligence, Gartner's AIOps concept focuses only on DevOps, whereas cloud intelligence has a much broader scope, including AI for system and AI for customer. We would like to extend the scope of AIOps to make it exchangeable with cloud intelligence. Now let's look at the scenarios of cloud intelligence. For services, the scenarios are around service health, specifically how to measure service health that spans multiple aspects, including availability, reliability, performance, security, etc. Using various metrics of components and resources, how to detect anomalous behaviors that may lead to service health problems. Furthermore, instead of passive response, can we predict service problems before they occur so that we can take proactive actions? And what actions can we recommend? For engineering, all the scenarios are similar, but many of them may present new challenges in the context of cloud computing. For example, incident triage is more complex than bug triage because incidents are unplanned service interruptions or service outages. Since online service systems are highly complex, one incident may lead to another and many others, meaning although these incidents are reported by different monitors, they're all related and share the same root cause. In this case, the traditional bug triage techniques may not be sufficient to triage incidents. For customers, let's look at intelligent customer support. To cut down cost and improve efficiency, how can we enable self-service for customers? How can we provide actionable suggestions to customers? When a customer does talk to a service support personnel, how can we help make the communication easier and efficient? The scenarios of cloud intelligence are quite broad. We may find more when we go deep into the space. When we explore the scenarios of cloud intelligence, we find that 4 major problem categories can be extracted out across different scenarios, namely detection, diagnosis, prediction, and optimization. Each problem has its own challenges. Let's take detection as an example. To ensure service health, at runtime, it is important to continuously monitor various metrics and detect anomalies in a timely manner. In the development process, for example, when you are doing continuous integration and continuous deployment, we should have mechanisms to catch the defective builds in order to prevent it from being deployed to more production sites. Both scenarios require timely detection. Furthermore, in both cases, there are common challenges for conducting effective detection. For example, time series data and log data are the most common data forms, and they are often multidimensional. The data may be noisy, and there may be different requirements on the detection, etc. On the right-hand side, I'm listing some of our work in the past few years trying to tackle some of the challenges in cloud intelligence. Now, let me use a couple of examples to make cloud intelligence more concrete. The first one is disk failure prediction. As we know, a lot of disk drives, both hard disk drives and SSDs, are used to store data in the cloud. Sometimes these disks may run into problems that cause virtual machines to go down and reboot, which impacts the availability of cloud platforms. A typical cloud system like Azure uses hundreds of millions of disks, making disk-related problems a top priority to address. To minimize the impact of disk problems, we would like to know about the disk failure before it actually happens. This way, we can take proactive actions to prevent the failures from impacting customers. For example, we can perform live migration to move the data on that disk to some other disks. To achieve this, we need to do prediction on whether a disk may fail after some time. To achieve accurate prediction, we fully leverage the spatial and temporal information about disks and build a machine learning model called Neighborhood Temporal Attention Model, NTAM for short. Through the collaboration with Azure partners, we have deployed NTAM in production. The second example is virtual machine pre-provisioning. VM provisioning is a system management process that creates a new VM on a physical host server and allocates computing resources like CPU and memory to support the VM. Provisioning is the most common and essential operation in Azure. Its performance, meaning how fast it is, directly impacts users' experiences. Therefore, the provisioning performance is one of the top metrics in Azure. To accelerate VM provisioning, a common practice is to get a pool of resources and pre-provision some VMs. This way, when a VM creation request comes in, if there's a match in the pre-provisioned VM pool, then this VM can be directly used to complete the rest of the provisioning process. Otherwise, the new VM has to be provisioned from scratch, resulting in longer provisioning time. In this pre-provisioning process, the pre-provisioning algorithm plays a critical role because it decides how many VMs should be pre-provisioned for each VM type. To design the pre-provisioning algorithm, let's look at what is known and what is unknown. The size of the resource pool is known, which poses a constraint on pre-provisioning. The historical demands for each VM type are known. The unknowns are what the demand will be in the future for each VM type. So we should predict the future demands based on the historical demands. The other unknown is how to fit the future demands into the resource pool. Since there may be many ways to do it, we should aim at the optimal solution. We formulated this problem as a prediction and optimization problem, and we came up with a unified framework to solve the prediction and optimization problem together. Our algorithm has been used in production, and it effectively helps improve the performance of Azure's pre-provisioning service. To summarize, I have talked about why we want to work on cloud intelligence and what cloud intelligence is about. After setting this context, together with my colleagues, we'll talk about what we have learned. Thank you.
Thank you, Dr. Zhang. It's really great to learn about the Cloud Intelligence workshop that Microsoft is arranging. So we will move on to the next question.
Our next question is for Dr. Fontoura. And so as a technical fellow and chief architect for Azure, this is a business-focused and product-focused question. How do you approach product strategy? How do you anticipate the needs of your customers in a field that is subject to very rapid innovation?
So thank you, Mahenoor and Anastasia, for organizing the panel. And it's a great pleasure to be here. And thanks for the question. So that's a very interesting question because this is a very rapidly changing field, and customers' needs are always evolving. So as we are part of a large organization, Azure, that is composed of several disciplines, including engineering, product management, and research, with our collaboration with our partners in Microsoft Research, like Dongmei, that leads the Microsoft Research in Asia, a group that we collaborate with, and we also have collaboration with the Microsoft Research groups in Redmond. So one of the disciplines that is very crucial for us is the product management discipline that, like Igal here in the panel, is one of the project managers that we have in Azure. And their function is to track customers and analyze like their utilization of the system and what they expect to get out of the system, so that we can also talk to them in terms of their expectations for the cloud in the next few months and years. And this, what we've been observing over the years, I've been in Azure for the last 6 years, is that customers' expectations for what we provide in terms of infrastructure for the cloud have been becoming more and more stringent, like in terms of performance, reliability of the platform. And these are the foundational areas that we always think about investing. So in terms of the question asking me, like, what are the areas that I tend to invest the most and what is the strategic for me? Always the foundational components where we can increase scale, efficiency, reliability. These are always top of mind, and also the quality of the platform, because these will address like most of the concerns that most of the customers will have, right? So we're already pretty good in scale, availability, and so on, but we're always striving to do better, anticipating the needs will become greater and greater in the future. And I know the question was not directly related to AI, but AIOps and AI and data in general is a fundamental part of all of this, right? So I don't think there is any feature in Azure that we build that we don't look into data and how can we use AI and how can we use predictions and how can we be very much data driven so that we can guide the resource managers that act on Azure, and then we can have ideas of like how much we can scale a given feature and how efficient we can run. So drawing in the parallels of other industries and like search, for instance, like search and ads in the past, like they were very successful in using data to predict like customer behaviors and predict like what customers want to see. It turns out that running the cloud at the scale that Microsoft is running, we can leverage the same type of data. We have a lot of data coming, we have a lot of information from the users, and we can predict a lot of stuff. So in terms of project selection and strategic decisions, we tend to really overinvest on the data areas and then machine learning areas, because these are like where we get the most benefit in understanding the infrastructure and also positioning us to be able to act quickly to solve customers' needs. And finally, I would just say to that point, like it's very, all this question about like which projects we should invest on. My job is much easier because I'm in Microsoft, and Microsoft people are very talented. We have like great engineers, great partners in the research groups that we collaborate with, great interns that come and work with us. So the ideas come from everywhere, and we have top-down ideas, bottom-up ideas, and we try to funnel working with the product managers to see like what of these brilliant ideas that are coming from everywhere we should invest, and which of those are high priority that align with the customer needs that we have.
Thank you, Dr. Fontoura. That is a very in-depth answer. I appreciate that. Mahenoor, over to you.
Okay, excellent. Thank you, Anastasia. So the next question is actually directed to Murali. So as a partner group engineering manager, you have the unique responsibility to take research and develop concrete, actionable solutions for your customers. So how do you incorporate the customer needs into the solution prioritization and development process?
Yep. First of all, thank you, Mahenoor and Anastasia, for the opportunity, and very happy to share the work we do here. So I'll say that to begin with, the purpose of my team's work is to give our customers the best experience. So given this, we are plugged into the customer's voice, that is, what kind of issues customers are reporting, what the expectations of the customers are, and what their needs for the platform are, etc. And what we do is with our analytics and continuous monitoring of the platform, we are observing what is happening to the customer experience and connecting that with what the platform is doing at any given time. And because of this, where are the areas that we can improve and will serve the customer needs. And we always have a running list of improvements that we can make in the platform to take care of our customers. So with this list, what we do is we have a bidirectional working methodology with our research team. On one side, we formulate the problems we need to solve to take care of our customers' needs in a way that maps to the innovations that are coming from our research team, some of which Dongmei mentioned earlier. On the other side, what we do is we look at the advances that the research team is making in any case and think about what are the practical applications for these innovations in our AIOps, right? And then what we do is we rank our list of things to do in the order of ROI, return on investment. That is based on what's in it for the customers in terms of serving their needs, what's the benefit for the platform, and what is the opportunity that this is presenting. So, and then once we get to that point, we go through experimentation and prototyping with our research team for the ideas that we pick jointly. And the reason I said for the ideas we pick jointly is because, again, it's all about priorities and then doing the best optimized work with the time and resources we have. And then the ideas that become workable, we take them to full production. The key word is the ideas that become workable. That means not all ideas work out. Sometimes it may be an idea that is too soon for the time, right? Or it may be an idea that is generating returns, but are really not as good as we expect, right? And we are very quick to fail fast if that is the case. But the ones that work, we take them to full production, and we have a very standardized process there. We do tons and tons of validation, and then we have lots of checks and balances in place, even for the AI. And most importantly, once we take it to production, we measure the improvements that these innovations and implementations have actually brought on. This is a continuous loop in that sense. And research is our engine in many ways. And that's the reason why you also see many of the patents and publications from us coming jointly with research. And some of the algorithms that Dongmei mentioned, the temporal, spatial, sequential, multidimensional, they're all building blocks for what we do here in the Azure platform and provide the best possible experience to our customers.
Thank you, Murali. I would ask the other panelists, would you like to chime in to add your customer perspective to this? Go ahead. Thank you.
Yeah, sorry. Yeah, I think it's critical when we talk about what to develop to take into account the customer perspective. I'll talk a little bit more in a few minutes about what does it mean. But I think in the end of the day, if we are unable to identify, to clearly identify and define the value, we cannot be successful with delivering AI ML functionality, both for the cloud, but for any systems that we have. And so I think the key here, really key here, is to distill the problem to something that we can measure, to predictions that can happen, and then we can engage engineering teams, data science teams, and kind of get the motion around it. But it all starts with clarity and crispness of the problem definition based on the customer feedback.
Thank you, Gil.
May I add something else?
Yes,
so
please.
One of the things that is very beneficial for us is that we're collecting data from customers that run in Azure. Of course, like the virtual machines that they run are a black box from us, but we can predict a lot of things like by analyzing how long their VMs live for, what are the CPU utilization and things of that source. So we can actually predict like how the workloads evolve over time. And this also guides us. So part of the job is talking to customers and taking feedback on what customers want now. And part of the job is also understanding and anticipating what customers will need a few years down the road. And AI and data analysis help us a lot in that front.
I will just add something there. That is, in some cases, before we even develop a solution, we look at the existing data and project the benefit. What is this going to give us? Is this something for which customers will have a need in the future, if not just now, right? So that's all part of our analysis in terms of collaborating with research and taking things into production eventually.
Okay.
Also, I want to quickly chime in here. So, from the, the points like Marcus and Igor and Murali made about like fully leveraging the data-driven approach, in how we build our platforms, how we operate our platforms. I think we can see that I think that is a vivid example of digital transformation. where how that impacts the software industry itself, right? So we are using it. I think that's a huge change compared to like years ago, right? How software was developed. So I just want to add that point.
Thank you, Dr. Zhang and everyone. So we will move on to the next question. Go ahead, Anastasia.
It is for Igal. We will put you on the spot. So speaking of artificial intelligence, how have you been specifically maybe able to leverage AI research and new solutions to transform some of the experiences for customers, since that is one of the key focuses for your team?
Yeah, thank you for the question. So first of all, let me start from making the main point. AI research is pretty much an integral part of our solution. And just clearly, it's very clear for us that we would not be successful without it, without having research, this deep connection with our data science team, engineering teams, and research team. AI allows us, AI and MLOps allows us to deliver significantly better experience with it than without it. And I'll share with you an example in a moment. But it's very critical for our system, and it's clearly understood that every feature we design, every aspect of the platform we develop, in order for it to work at the cloud scale, we need AI and ML and data support behind it. Data processing and AI are not only reserved for customer behavior and behavior analysis and interaction. Why won't we let machines manage the machines? This makes perfect sense. As a customer advocate, my goal is to solve the top customer issues. And I work, as I mentioned, with engineering and data science team and research. Our goal is to ensure that customer voice is clearly heard. One major area in which we heard the customers complaining was reliability. What can we do with MLOps, AIOps to improve reliability? Reliability is all about fixing the issues. Look. And so the question that we asked ourselves is, can we define the impact to the infrastructure and user applications that are running on Azure infrastructure? We were able to define goals in terms of specific reliability aspects that might impact customer applications. And we define them, we define them as interruption rates, annual interruption rates, or funny acronym AIR in short. Once we had the goal, and once we had the objective functions defined, we could start predicting the reliability impact based on past platform behaviors and trends of the new behaviors. With efficient algorithms that were developed in partnership with research, we were able to effectively predict downtime across the cloud. And this is huge scale, so we needed some extra special support and extra special processing in order to achieve the right performance levels and implement the behaviors we needed across cloud. But with those efficient algorithms that were developed, what can we do with that information? And let me step aside and define another aspect of those large distributed systems management. In the past, systems were mitigating observed failures. There was a failure, operating system or any distributed management system would step in and mitigate that failure. But now that we have prediction, we can perform speculative mitigations. We could avoid future potential impact. And this is not a dream. Majority of the downtime today is avoided using this methodology. We published multiple papers and blog entries on the topic. And now when we have those new predictions, we can actually step in and implement new operations for the cloud, for the operating systems, for the hosts, that allow us to take speculative recovery actions. So we can maybe take some lower impact and perform recovery before failure happened, instead of waiting for failure to happen and then perform a more impactful recovery on the customer application. And so we invented a bunch of new operations that can be taken in response to those potential failures. And by the way, we call this family of operations tardigrade. This is microscopic animals that just cannot be killed. It's very resilient. And this is how we envision our systems. Whatever happens to them, they can still recover. And we could potentially take those transparent maintenance operations and implement them instead of waiting for the failure. We actually did a demo a few years ago when we introduced this methodology. We had two machines, two hosts, one managed by ML operations, one without it. And we simulated transient failure on both machines. One machine, of course, crashed. Another one experienced a hiccup, but continued running. And this is because we were able to quickly predict and recover it prior to the actual customer impact. So I think the bottom line is the value is clear. It's a major tool in our toolbox. When we design our products, we don't even imagine going to the product discussion without understanding what kind of data we will use and how we can leapfrog the naive experience that customer would get without this data and ML investments. It's almost obvious to us that without it, we are not shipping feature, we are shipping a prototype. So it's a major toolbox. It's a major tool in our toolbox when we use it correctly. Thank you.
Thank you. Any other panelists like to add in to Igal's observation and deep answer?
I'll just say +1 to what Igal said, because he talked about mitigations as well. And one of the biggest innovations we have made is machine learning AI-based mitigations that we can take to minimize the impact to customers.
And then I think just one point here that should be obvious, but at the scale that we are operating, we need to handle failures because like probability of a disk failing, for instance, is like, let's say 1 in 10,000, but you have a way more than 10,000 disks. So things will fail, and software will fail. There is enormous combination of like customer software running, firmware, new hardware generations, new versions of data center architecture that we roll out. So this is like in aggregate, the infrastructure that we run across the world is very disparate and is very hard to control. So there will be always some level of ambient failure. And the idea is, how can we use AI to really understand, classify, and automate so that the humans don't need to be in the loop most of the time?
Okay, excellent. We will move on to the next question. And this question, we are coming back to Dr. Fontoura again, and it's also a continuation on Azure. So what problems does Azure solve for your customers?
The premise of Azure and what it's solving for the customers is really, we want to provide the compute abstraction for our customers, and we want the customers not to be bothered by all the infrastructure details that we can take care of for them, right? So basically, we want to automate away all the maintenance that needs to be done, all the security work, all the efficiency work, so that we make sure that the infrastructure that we provide for them is very cheap and cost effective. Updates of new versions of software and so on. So we want customers to get an out-of-the-box experience that works better than they had like a computer under the desk or in their on-prem data center. And as Igal just said, and Murali and all my panelists friends here, that if we had at the scale that we're operating, if we didn't have AI and we didn't have data, we simply cannot handle it. We would have to have too many operators involved to be able to handle the scale that we have. Like, so the automation that we get from AI and the level of automation that we get for predictive, let's say, failure recovery already, it's a huge time saving for us, right? Like we have like a very large number of data centers across the world that like where we have like operators running, and we don't want like these operators to be replacing disks left and right. If you can predict that the disks are going to fail ahead of time and take mitigating actions that we avoid having customer impact. So this is all huge for us, and both the automation and the predictive power that we get from AI.
Thank you, Dr. Fontoura. So we will move on to the next question.
The next one is for Dr. Zhang. What are some major advancements in your scope of AI research that you anticipate are possible within the next few years? We want the inside scoop into your research lab.
All right, thank you. Thanks for the reminder. Sometimes I make that mistake. All right, thanks for the question. I think just now, like Igor and also Marcus talked quite a bit about like prediction, right? How that is important in AIOps. Actually, I would say definitely the one of the advancements in AIOps in recent years is around prediction. So there has been a new concept together, we're promoting. So we call that proactive system design. Maybe let me explain that a little bit first. So if we look at a software system, a traditional software system, it does not have this so-called proactive system design, meaning it can only react to the signals, to its current status. So it's quite reactive. But if we have a system with the so-called proactive system design, and then meaning it has a prediction component, like Igor and Marcus just talked about, then it will be able to know what's going to happen in the future. For example, like when it's likely for a disk to fail in certain period of time, or when the status of your cluster would look like. So in certain time, if we have that like future piece of information about the future, then that will give us the opportunity to take actions. So that is about the prediction part. But in addition to that, there is a decision-making part associated with it. So both Igor and Marcus talked about taking actions, right? But what actions to take? There may be multiple choices. If we take this one, do we know this one is the best one? Is that a learning process for us? Meaning, can we kind of explore the impact of taking these actions? Maybe next time, we learn that there's a better action we can take next time. So there's opportunities here to for us to learn how to better design the decision component, which is different from what was in there in the past in traditional software system. So this is what we call the proactive system design. It has the prediction part. It also has the decision-making part. If you look at the research, AIOps related research in the community, then in recent years, there has been a very active research around the prediction part. There is some research published around the decision-making part. Like together with our Azure partners, we have been researching into both. And in production, I believe we also have like cases trying to leverage the proactive system design. So in the next few years, hopefully, we'll be able to see more and more such cases, such methodology, like in our system. But like Max was saying, right? So the whole this whole process it's not easy. It's definitely a learning process for all of us. So we need to keep continuously improve our research, our technologies, in order to achieve the great results. Yeah, thank you.
Thank you, Dr. Zhang. And the panelists, I would request, would you like to add to what's coming next in AI world?
I think the key point that, one of the key points that Dongmei made is decision-making, right? How can we, as Marcus was saying, with the scale that we have, with the amount of data we're receiving, and with the number of failures that can happen in such a large distributed system, how can we make the decision-making process easy and fast, such that the impact to customers is minimized, right? And that is where AI is playing a bigger and bigger role. And I see that as the biggest advance that will happen in the coming years.
I think the complexity of the systems is still increasing. We are getting, the cloud technologies are becoming more and more complex to manage, more and more centralized. And the role of being able to predict the customer behavior, the application behavior is critical. Without it, we will not be able to be cost competitive. In many cases, we need to know what the customer will do in order to identify just the right amount of resources to assign. So I think as the technologies of the cloud continue to develop, we'll take more and more dependency on predictive insights. I suspect that, at least I'm looking a few years ahead, I suspect that the vast majority of our operations, of our revenue could be traced back to predictive insights around our customers' behavior, applications behavior, systems behavior.
Okay, excellent. We will move on to the next question. And this question is directed to Igal. So what should public company board directors be aware of regarding AI?
That's an awesome question. Thank you. So I think in the past, the goal of the company board, and I'm saying in the past because it's a traditional goal, was to look into the performance of the company and define maybe new KPIs, look at the existing KPIs, and define policies. But are those KPIs that have been defined enough? What if we could look into the future, look into potential set of scenarios, and take decisions based on multiple passes lying ahead? So not just use past data, but use future data in order to take better decisions. I think companies and boards that are not using future decisions are at major disadvantage. But there is even more than that. This is not just happening at the board level. I think the boards will need to hold every layer of the company accountable to this digital transformation so that those insights are available for every business decision, for every business operation. We are coming here to talk about the systems analysis. And of course, our companies are tech companies, and many of us are working for the tech companies. And so many of the board decisions would influence our technical strategy, but it's not limited to the technical strategy. So I think the bottom line, boards that don't recognize the value of machine learning and AI might be operating in the world of yesterday.
Thank you, Igal. Okay, so a great discussion. Now we'll move on to audience submitted questions. A lot of questions were submitted by our participants during registration. A few of them we have already discussed. So the first question is submitted by Videhi Malela. And this question I will direct it to Dr. Fontoura. So the question is, what are the top challenges you are facing today, and how do you see them evolving over the next 12 to 24 months?
Yeah, thanks for the question. That's an excellent question. And I think I alluded a little bit to the challenges that we have today, but as I mentioned before, I think the demands that customers are having, the cloud platforms are becoming more and more stringent in terms of performance, more complex systems being built, very large scale systems being built. So the latency and scale requirements that are imposed in the cloud systems are very high. And of course, like the goal for the cloud provider, such as Microsoft, is to meet these requirements while keeping the efficiency for the cloud in check, right? So I cannot be very wasteful, because and customers wouldn't want that, because sustainability is also something that customers want, right? So customers want like very, very hard things to meet, because they are often conflicting. They want a lot of scale, they want a lot of performance, but they want us to do it in the most sustainable way with green energy, and like the VMs have to be the most optimized possible so that they can meet those requirements. So the challenge there is that like the biggest challenge is the scale, and the biggest challenge is the complexity that we have in terms of the workload. And to meet both of these challenges, like the investment is in the intelligence. Can we use intelligence to understand the workloads better, to understand how workloads do recovery, how workloads do graceful degradation, what are really the scale out stories, so that high availability stories, so that like we can leverage this information. So then when we are planning the resources and when we are planning the operations for the different systems that we deploy, we can do it in a way that will meet the customer's need, while also like being efficient for Microsoft. So that's like a big area of investment for me, and investment on data and predictions to support that is also huge.
Thank you, Dr. Fontoura. Okay, I guess then we will move on to the next question. I will direct this question to Murali. So many industrial use of cloud computing comes with an edge component, especially if there are likelihood of connectivity loss or bandwidth constraint. How is AI being used in edge computing? Can you talk about some examples?
Yeah, so currently one of the ways to use AI in edge computing is through offline means, and this is an excellent question. So what we can do with these edge systems is we can collect a great deal of data locally, and we can aggregate that data on the edge systems themselves. But again, like it was mentioned in the question, the problem is you don't have very solid connectivity all the time, right? So the large volume of data that is collected and aggregated at the edge device level can be batched and sent over to the cloud when there is connectivity in a condensed manner and what is really necessary manner. And then one of the things we do is use that data on the cloud backend side to develop, to do offline learning. You have the data and you have the computing power in the cloud backend, and you can use that to really analyze the data and develop the models that are needed for managing and maintaining what you need to do in the field through these edge systems. And once this model is developed and tested, the models can be deployed on the edge systems themselves. And then the whole idea is to use these models at runtime on these edge systems to make decisions. They don't have to do the actual AI part on the systems, but use the results that have been obtained by learning offline. So that is the way that the industry is evolving today. That said, like with everything else in the industry, these edge systems themselves are expected to become more powerful, and connectivity is expected to get better with time. And that in the future should give way to being able to do some level of AIOps on these devices themselves without completely depending on the backend alone. Right? And some examples are the systems like offshore drilling, right? You don't have connectivity from there all the time. And the computing power there is not very high either. They just have what they need to do the job there. So you can collect the data and use the cloud to really get the results that you want.
Thank you, Murali. So we are actually ready to wrap up. And now, on behalf of the Harvard in Tech Seattle, thank you for your time today. Our panelists, Dr. Zhang, Dr. Fontoura, Murali, and Igal, thank you. It is a great pleasure to have you as our panelists. It was an informative session, and we have learned a lot. A special thanks to Zhang, a Microsoft Program Manager. She helped us tremendously in the background with this collaboration. Thank you, Jen. And last but not least, Anastasia, thank you for your help in partnering with me in this collaboration. So to the participants, thank you for joining us today. It is remarkable how significantly all of our lives have changed over the past year. We hope you and your loved ones are staying safe, healthy, and getting vaccinated during the COVID-19. We are grateful for the connection and strength of the Harvard alumni community. Thanks to your generosity and support. Hope this webinar will bring in some thought-provoking discussion. If you are interested in learning more, please join us at Harvard in Tech Seattle. Thank you and goodbye for now. Bye.
Thank you. Bye.
Thank you.